Real-time operating system, we'll look at what is real-time operating system and how it works. So real-time operating system is also called RTOS. It's a specialized operating system. It is an operating system like Windows or Mac OS or Android, but it is specialized. That is, it handles real-time tasks and processes in embedded systems. It is specifically designed for embedded systems, that is small systems which have minimum resources, that it will have less RAM or less space to run. So unlike the general purpose system or operating systems such as Windows, Linux or Mac OS, which prioritize tasks based on factors like fairness and efficiency, that is, it has more space. RTOS are designed to prioritize tasks based on the timing requirement, that is, you have very small space, so you need to run the software quickly, and that's where RTOS comes off. Like many of the hardware small embedded system will have a real-time operating system. Some are, like I have worked on Green Hills, which is typically used in avionics and in automotive systems. Green Hills is a company which provides like Integrity. I think it's a Integrity RTOS, and there are also other Linux-based RTOS systems which could run on. It's basically a very small system. The normal Linux system could be a big package, but if you take the RTOS, it will be very small since it's like optimized. And some of the key characteristics we look here. First will be the deterministic behavior. So RTOS are like deterministic, meaning they guarantee that the tasks will be executed within the specified time constraints. So within some specific time it will respond or it will do the action. So this predictability is essential for applications where timing is critical, such as industrial automation, automotive systems, medical devices and aerospace. So within certain time something should happen and the software will respond in that time. So 100% or more than 100%. So that's why it is called deterministic, that is, you can depend on it. So in medical or life threatening or in aviation, where the flight landing and takeoff, all these things are time critical things. So this is what we call RTOS systems are deterministic, that is, you can plan things based on that. Task scheduling is RTOSs are use various scheduling algorithms such as priority based scheduling, round robin scheduling or rate monotonic scheduling. So these are some of the types of priority. So priority systems, how you prioritize certain tasks to determine the order in which the tasks are executed. So in task scheduling means like you schedule one task after the same, like you prioritize tasks. When you get up in the morning, you say I have some set of tasks in your mind and you prioritize some tasks like higher priority than the others. For example, dropping your kids to school, or maybe just taking a walk might be lesser priority, but dropping the kids to school is higher priority. So those sort of things to determine the order in which the task. So to determine which is prioritized higher and lower, we use like the technique mechanisms for handling interrupts, which are signals generated by hardware devices to request attention from CPU. So interrupt services routines, which we call ISR, in RTOS have a minimal latency and predictable execution times to ensure timely response to external. So interrupt handling is like something like a program is running and suddenly if it is being interrupted, like when we are doing some task and someone comes in between office time and asks something, so that's an interrupt. So we stop what we are doing and then answer them and then go back. So this is what is called. Similarly, in computers we have programs which are running continuously and then interrupts come, like a sensor might send a signal, then this program stops, gets the sensor data and then continues. So something like that. So RTOS provide efficient mechanism for handling these interrupts, which are signals generated by hardware devices. So when we say signal generated by hardware device, it means the sensor could send them data or the motor gets stopped, something like that. So it sends a signal. So the CPU stops and then it services the routine, interrupt service routine. That's why we call interrupt service routine in RTOS, which have minimum latency and predictable execution times to ensure timely response to external events. So this is very important. It has to respond quickly, like in embedded systems, because like these are time critical things in aviation or in medical. When you're measuring some data of a patient, and the sensor constantly sends data, and it should be visible on the display, otherwise the doctor might interpret it wrong. So this program should constantly read the sensor data and then show it on the display, so that the doctor can diagnose, or the beep can go on if it goes above a certain or lower than. So kernel services means RTOS offer a set of kernel services and APIs, application program interface APIs, for managing tasks, synchronization, communication, memory allocation, and timing. So these services allow developers to create and control the real-time processes efficiently. So these are what you call kernel services. It's a set of kernel services and APIs which manage task synchronization. So there could be many tasks, and each task will synchronize with the other task. So that's what we call task synchronization. And these services allow developers to create and control real-time processes efficiently. Concurrency and multitasking. RTOS support concurrent execution of multiple tasks, allowing embedded systems to perform multiple functions simultaneously. It can do two things at the same time. RTOS manage task switching, resource allocation, and synchronization to ensure efficient multitasking without compromising the real time. So RTOS manages which task is prioritized, which tasks take which hardware resource. So those, if you have a multi-core processor, so one task might be running on one processor, another task might be running on another processor. So someone has to manage which task runs on which processor. So this is what RTOS is good at. So concurrency and multitasking. Resource management. RTOS manage system resources such as CPU time, CPU memory, memory, IO devices, input-output devices efficiently, ensuring optimal utilization and preventing resource contention. So the resource management is an important thing to meet real-time work. So the resource should not be overloaded, or it should not be underused. So this is also managed well in RTOS with that is the CPU time, memory, IO devices. These are the resources. So what are the resources? Resources basically CPU time, memory, IO devices are the resources, and it has to be managed by the RTOS. It is low overhead. RTOS are designed to have minimal overhead in terms of memory footprint, context switching time, and interrupt latency. So this low overhead is critical for embedded systems with limited resources and stringent performance. So low overhead means like designed to have minimal, it runs on a very small hardware, and context switching time is quick, interrupt latency switch is quick, and this low overhead is critical for embedded systems. So this is another important point. Hard real-time and soft real-time. Soft RTOS have maybe classified as hard real-time and soft real-time based. So two classification based on their ability to meet timing. So hard and soft real, we say based on their ability to meet the timing deadlines. So hard real time means must meet all the deadlines consistently. It should. There is no other way. It should always do that. That is what we call hard. Soft is can tolerate occasional misses. So this is what is called without causing catastrophic consequences. So this is hard is should meet all the timing requirements, and soft is it might miss something without causing any issue. Then finally summarizing, overall RTOS play a vital role in embedded systems by providing a platform for developing, executing real-time applications with deterministic behavior and predictable performance. They enable development of mission critical systems that require precise timing and responsiveness. So RTOS is a very important part of embedded systems. If you are learning, so you need to understand the basic concept. Hope I have made it clear. If you have any questions, do post on the comments.